Kia ora. We had looked at this one before, but now this is part two because we're going to look at the second part of the question that came from the 2021 exam. So in the first part, we looked at this to draw a ray diagram to find where we would find the coin or where we would see the coin. Is remember light changes direction if it goes from a say water to air because it goes at different speeds. So the things we chose is first draw a guiding line, then you can draw your first ray going to the surface, then the normal, then you make the refracted ray bigger, so it'll go away from the normal to the bottom of the eye. And you do the same thing with a second set. And the reason why you have two rays is because they need to converge at a point. So we extend these back. And these are dotted lines because these are virtual light rays that are not real. We can't see them. You can wave your hand in there and you won't be disturbing any light rays because they're not there. It's just our eyes. Our brain fools us that light travels in straight lines, and that's why we see the image here. But the question also asked in part B is we can also see a second image over here because this beaker is made out of glass, so we see it through the glass. But we don't see it in the same way, and why not? And draw ray diagrams to find out. So again, you choose a point, and we're going to choose the same point, draw the ray diagram, draw the incident ray till it hits the surface, an interface from going from water to air. I mean, I know there's glass in between, but it's thin, so we're going to ignore it. Now we draw the normal, and the normal is always at 90 degrees to that interface, so between the water and the air. And now we must make sure, because we're going from a more optically dense to less optically dense, that the angle of refraction is greater than the angle of incidence. So this over here is our incident ray, always between the normal and the incoming ray. Then the outgoing ray and the normal is the angle of refraction. And so there we draw our line again. Now we do exactly the same thing with a second ray. And again, we need that second ray so we can get a converging point. So here we go again, draw the normal. The normal is really important because it helps us check whether your angle, your incident ray is going to be smaller than your angle of refraction. And there we go. We've got our two rays over here. You see it in straight lines, so you extend this backwards. And there's the first one and the second one. So that point where they cross is this point over here. Now you've got to go, do I draw it like I did over here, or which way does it go? Now what happens, the image will be parallel to the surface. So when we were going upwards, the surface was horizontal, so the image is horizontal because this coin was horizontal to it. But now here we've got our uh, interface vertically to the coin, so our virtual image is actually going to be parallel to that interface surface. And if you're not sure, you can always check by drawing more rays. So let's take a point from here, draw a ray and go to the eye, draw a second ray and go to the eye, extend those backwards, and you'll see the point where they converge is down here. So the top of the coin, or that left part, is now at the top, and the right part is now at the bottom. So hopefully that shows you how to draw a ray diagram. It's the same steps, it just looks more complicated because we made things go sideways because we're seeing through the glass. Here we just simply see through the top of the water. Kia ora.